No.
Ahí está.
Hi, how are you? We are going to present topic of heavy wall pressure vessels. Um, my team is Paula, Mago, Olascuaga, Victor, Alan, and me.
Uh, Introduction. Unlike thin wall vessels, the walls vessels have to be considered one designated and uneven distribution of strip across the wall thickness. The state of stress in a thick water container subjected to internal pressure has three axes. A normal stress are formed radial, tangential, and axial stress. Since the stresses that occur in a container are not measured directly, it's determined by measuring the deformation of occur on the surface. The deformation are measured by means of strain, gauge, and from them the stresses are determined.
Okay, very good. Um, Manufacturing process. Okay, pressure vessel fabrication is an extremely complicated process. It is a detailed and precise process. It involves the control coating, forging or rolling, bending, welding, and assembling process of metals for vessel fabrication. And because pressure vessels are manic designed to fulfill tasks on transport and store of liquid or gas materials. Finish.
This will be defined as the time of carrying out the design and restricted calculation because site thickness will depend mainly of pressure different and tensions to which the ample will be subject for thick wall pressure vessels. Shear wall thickness is generally greater than one-tenth of the shear's main radius. In this case, there's variations between in the inner and outer surface become oppressed and ordinate average straight forms are not accepted. Um, we have pressure vessels. What has most pressure vessels are made from a sheet meat that has been meant to in the necessary curve.
Hello everyone. Good evening. In this problem, you will see how to solve a problem of a pressure vessel as shown in the figure. In the problem, we will find the maximum shear stress. We will use the following equation where we'll square the 15 PCE and multiply it by in the 10,000 PCE, and we will divide them by 15 squared minus 10 squared. This will give us a result of 18,000 PCEs.
Hello everyone, I will show you what the nomenclature is and the types of analysis since the nomenclature is going to be used to design the problem as our colleague Alan told us. Thick wall pressure vessels as well as most pressure vessels are made of metal sheets that have been given the necessary bend so that the cylindrical spherical vessel shape can eventually be obtained. The nomenclature for thick vessels are A equal inside radius of thick sphere or cylinder, B equal outside radius of thick sphere or cylinder, FMER equal meridional or axial stress, FR equal radial stress, FR max equal maximum radial stress, Ft equal tangential or circumferential stress, Ft max equal maximum circumferential stress, Pi equal internal pressure, Po equal external pressure, R equal cylindrical or pole coordinate.
Talking a little about the characteristics of this component. When a pressure vessel is made, it can be of different shapes, the most common being spherical and cylindrical. However, once the shape of the pressure vessel has been defined, its involved must comply with the thickness with which in will be manufactured, complying with the standards. This will be defined at the time of carrying out the zinc at the recipient calculation, because side thickness will depend mainly on the pressure difference and the tension to which is involved with the subjects. For thick water pressure vessel, the wall thickness is generally written of the untried man radius. In this case, a straight variation between the inner and outer surface become appreciable and the ordinary average stress formulation are not acceptable. Heavy water pressure vessel has will not pressure vessel are made from set metal that has been ventilated in the necessary curve, so that cylinder and cylinder shape and equally obtained.